So this video is going to look at plotting polar coordinates. So we've spent a lot of time dealing with rectangular coordinates in our mathematics career at this point. So rectangular coordinates are in the XY plane, and probably with no trouble at all, you'd be able to plot points like 2, 3, and maybe -4, 0. That's totally something we're comfortable with and something we've been dealing with for years. What we're going to look at today to start our lesson is something totally different. This is the idea of polar coordinates. Polar coordinates, the biggest difference here is that these are used to plot points on a circular plane. So you'll notice right away here, this graph, the grid is not made of rectangles. It's actually made of concentric circles. So circles that are stacked inside each other, right? So just kind of unpacking this a little bit. We have a circle out here of radius 4. We have a circle inside of that of radius 2, okay? And this might look familiar in setup because of these lines coming out from the center and cutting across all of those concentric circles. Those are called radial lines, and we've actually seen a bunch of these lines in our use of the unit circle, right? Here's pi over 6, here would be pi over 4, pi over 3, pi over 2. So again, these lines that I'm drawn that are going from the origin out to all of those circles, those are called radial lines. Radial lines, and I'll be referencing them through the video. Another piece of vocabulary that we're going to need to be comfortable with is this idea of a polar axis. And that is the positive x-axis here. And I'll make that a little bit smaller. So just this one side of the x-axis is going to be our polar axis. Okay, so a couple things going on here. We have polar axis, radial line, and then those concentric circles. Okay, so let's see how that affects this idea of polar coordinates. Our polar coordinates are written as an ordered pair where the first letter or the first component is r, and that is our radius between the point and the origin. Okay, so if I plotted the point here, I could see that the radius is 4. If I plotted a point, let's say out here, that is a radius of 2, 4, 6, and actually 7. So radius of 7. Okay, so the radius is a big component of our polar coordinates, and then the second component is theta. And theta is the angle measured between the ray, and the ray that I'm talking about would be a ray connecting the point and the origin, and the polar axes. Okay, so if I plotted a point right here, that would have a radius of 4. Right, you can see that it's 4 units out from the origin. And if I were to draw a ray that connects the origin and that point, there would be an angle measure between that ray and the polar axes of pi over 3. And I know that because that point is plotted on the radial line corresponding with pi over 3. All right, so we're going to go ahead and practice this idea first in radians and then in degrees. So point A, let's unpack that. It says we have a radius of 2 and theta value of pi over 3. So on the radial line corresponding with pi over 3, we need to plot a point that is 2 units away from the origin. Okay, so looking at our polar grid, or coordinate grid, we'll kind of think, okay, well, here's my polar axis. If I need to build an angle measure of pi over 3, I need to be plotting along that radial line. And where specifically is given to us by the radius. So we have a radius value of 2. So we need to be 2 units away from the origin on the radial line that corresponds with pi over 3. So there's our point A. Just to kind of help keep track of things, I'm going to actually erase kind of all this accessory notation as we move on to point B. Point B says that radius is again 2, but our theta value is negative pi over 3. Okay, so we need to go find the radial line that corresponds with negative pi over 3. So focusing here on my polar axis, I need to go in the negative direction and plot along the radial line that would build an angle between these two rays of negative pi over 3. Okay, so we know that we're building out on that line, and also actually corresponds with 5 pi over 3 if we had gone in the positive direction. And because our radius is 2, we know that we need to plot 2 units away from the origin. So point B lives there. Okay, so in point C, we are told that we have a radius of 5 and a theta value of 3 pi over 4. So up on our grid, we need to start here on our polar axis, and we need to go ahead and plot along the radial line that corresponds with 3 pi over 4. So we know that this angle here would be 3 pi over 4. So on that radial line, because our radius is 5, we need to plot 1, 2, 3, 4, 5 units away from the origin. So we'll go ahead and put point C there with a radius value of 5, theta value of 3 pi over 4. All right, point D, again, we have a negative theta value, so we'll be going in the negative direction, but we have a radius of 3 and a theta value of negative 3 pi over 4. So starting at our polar axis, we need to go ahead and build in the negative direction an angle measure of negative 3 pi over 4, and I know that that will be on this radial line here. That's the same radial line as 5 pi over 4. Because my radius is 3, I know that I can plot point D. Oops, nope, that's at 4. Point D is actually here, 3 units away from the origin. Okay, so next is point E. We have a radius of 4, theta value of 7 pi over 8. So this is a little interesting, a little different than what we're used to, right? 7 pi over 8 is not a unit circle value, so it's maybe something we haven't seen before, or maybe something we have seen before but aren't super comfortable with. But same idea applies, right? We're going to start at our polar axis, and we're going to build out an angle that corresponds with 7 pi over 8. Something that I notice is that 8 pi over 8 is equivalent to pi, right? So if I had 8 pi over 8, I would be plotting along that radial axis. But I don't have all 8 pi out of 8. I have 7 pi out of 8. So I need to be a little bit above that horizontal axis. Okay, so, and if you want, you could convert this to degrees and see that 7 pi over 8 corresponds to 157 degrees. In radians, it's just a smidge larger than 5 pi over 6. Okay, so it's somewhere along here, okay, along that radial line. And we're gonna go ahead and plot point E 4 units out from the origin. All right, last one for this video is point F. We see that point F is corresponds to a radius of 4 and a theta value of negative 2 pi over 3. So when we look at building that angle, we're going to start at our polar axis and go in the negative direction, an angle measure of 2 pi over 3. That's going to correspond with our 4 pi over 3 radial line. So we're going to be plotting along this radial line. And we're told that our point is supposed to be 4 units out from the origin. So we can go ahead and plot point F right there. Okay, so hopefully this video helped you understand what these points represent and also how to plot them.